Welcome to ClickMyProject.com. Our project title is VLSI design and an FPGA implementation of an ATT hardware accumulator for the homomorphic seal embedded libraries. Our project abstract is a CMOS technology refers to the scaling threshold evolving the non-volatile memory. So it based on the VM. So approach the beginning of the hopeful dynamic RAM. So DRAM based on the low leakage power and improved stability, scalability of advanced encryption standard using the algorithm we have using the encryption for the ciphertext and then plain text conversion. So runtime performance overhead the energy are evaluated. The cost sensitive memory, the logic operation capability of using the non-volatile memory was utilized to the employ of the proposed AESIM technology. Is a Xbox technology for the AESIM methodology of for the performance. This technology is called based on that both encryption and decryption process measuring the minimum time used, area power delay we have calculated, the before clocking delivery and an average time requirement operation after clock, latency and amount of logic separately proposed AES algorithm is with the encrypt and then decryption techniques. Our project flowchart is the plain text input 128-bit we have taken. So after the add round key. So for example, the hello world as a input text. So we have converting to the hexadecimal value after using the add round key. After using the subnets. After the shifting row operation, mixed column operation. So for example, 0 1 0 0 means if changing to the shifting method. So 0 0 1 1. So after that is 0 0 1 0 after the 1 before that element. So this is a mixed column operation and shifting row operation. After that the add round key will be generated using the XOR gate. That gate wise we are using the sub bytes and row and add round key. Finally we have convert to the ciphertext format. So this is a plain text to ciphertext conversion. After the reverse process everything based on the cipher to plain text conversion. This is the encryption and decryption process based on the Verilog part. Architecture delay the 8-bit multiplier. So they using the Verilog code. So using some Xilinx ISC 14.7 we are using the implementation of Verilog code. So this is a multiplier concept. So this is a two model, one is a behavioral model, another is a simulation model. So behavioral check the semantics have successfully. After the simulated behavioral model, so weighting the complexity of the CPU basis. So this is a CPU based on the 936 seconds. So this is a input data. So after that this is a RTL basis. So first set the constant force value 001. This is D1 generation. After this values and then clock set based on the 0 based on off and 1 based on the on. So clock set on. So and then reset based on the 0. So this is the input. A and B has the input. This is a clock set. This is the finally output. So this is a proposed of a